Alright, in this video we are going to graph a couple of piecewise functions such as this one. So you can see that this function is written in two different parts or pieces, and we're just going to graph one at a time. So let's start by graphing this blue piece. Now when you look at this, see the 2x minus 3? You should be thinking y equals 2x minus 3. So really we're just going to graph this linear equation, y equals mx plus b. Now remember, when you graph a linear equation like this, you start with the y-intercept, which is negative 3. So there I go. Now the slope is 2 over 1, so that would be up 2 over 1, like this. Okay, and I could continue the line in the other direction all the way across the paper like this by going down to left 1. Okay, now I'm not going to draw the line yet because this line is not defined for all x values. This piece of the function is only defined for x values that are less than negative 3. Now, some kids think that we'll start at negative 4 because that's the next value that's less than negative 3. But if I skip from negative 3 all the way to negative 4, I'm skipping a bunch of decimals. So I don't want to do that. This is going to be a little bit weird. So we actually start at the value, the x value that is right at negative 3. Okay, so this is the value that's at 0. We're talking x values. This has an x value of negative 1. This has an x value of negative 2. This has an x value of negative 3. So this is the point at which you should be focusing. So this is going to be the cutoff point. Now, see how it says less than? So this should actually be an open circle. So I'm going to erase this and replace it with an open circle. Okay, so we're going to have an open circle. Now, sometimes we keep the part of the line that is to the left of negative 3, and sometimes we keep the part that's to the right of negative 3. In this case, we're supposed to keep the part that is to the left of negative 3 because it says less than. Now that's going to be tricky here because we're almost at the edge of the graph, but just understand this. If I kept going down 2 over 1, like my next point would be about here. So I need to draw the part that's going to the left of negative 3, so I need to draw this part, not this giant part over here. So that's what I'm going to do, even though it's going straight off the graph. Okay, I'm going to draw this part. And then it's going to disappear, but then I'm going to draw it again. Okay, so I drew the part that's to the left of negative 3. So I can actually erase all the rest of this, because this is the part that's to the right of negative 3, and that's not what we wanted. Okay, so that's what that piece is going to look like. Now let's look at the other piece, which I will do in pink. So again, when you look at this piece, you should be thinking y equals 1/3 x plus 2. So let's graph that. So we start at 2, because that's the y-intercept, and then I go up 1 over 3 from there. All right, I can continue the process in the other direction by going like this. Okay, now again, focus at the point that has an x value of negative 3. Okay, this has an x value of 0. This point has an x value of negative 3. So this is the one that we want. So focus your eyes on this. Maybe I'll make it bigger. All right, focus your eyes on that. This will be a closed circle because it's or equal to. So the question is, do I want the part that's going to the left, or do I want the part that's going to the right? So see how this is greater than or equal to. Because of that, that means we want the part that's going to the right. All right, to the right of -3. So here we are at -3. The part that's going to the right is the part that looks like this. So that's the part we're going to draw. And we will erase these other 2 points. So that's it. That's what the graph looks like. All right? It's going to be this and this. Notice how this passes the vertical line test. Remember, if I have a graph, imagine I had a graph that went like this. And then I had another piece and it went like that. This would fail the vertical line test because a vertical line would hit more than 1 point. So this wouldn't be a function. All of these should be functions, every single one. So just always glance and make sure that your graph passes the vertical line test. Anyway, let's talk about the domain and the range and increasing and decreasing. Okay, so the domain. Well, this graph goes to the left forever and it goes to the right forever without missing any x values. All right, this one stops at -3 and this one begins at -3. So nothing is left out. So the domain is -infinity to +infinity. Now the range, for the range, we're going bottom to top. But for the range, there's a giant gap right here. So looking at the blue part, okay, for the range, it's going to go from -infinity to -9. Okay, so I'll have -infinity to -9. Now I'm going to leave it round because that's an open circle. Then I'm going to say union. And now there's a big gap because look, imagine a horizontal line to help you understand what I'm doing. Okay, so you see this horizontal line. Make it a little thicker. Okay, so you use a horizontal line to imagine what the range is doing. So this blue part goes from -infinity to -9. But then we got nothing all in here, in this space in here, nothing, 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 nothing. But then here we are touching the graph once again at 1. So this pink part of the graph is going to go from 1 on up. Okay, so it's going to go from 1 to +infinity. And this is a closed circle, so I will include that 1 by making a bracket. So that's what the range would be for this graph. Now, how about increasing and decreasing? From left to right, I would be going uphill along the blue part of the graph, and then I would still be going uphill for the pink part of the graph. So I'm going uphill over the entire graph. So I'm going uphill at every single x value. I'm going uphill. So we're increasing over the entire domain. So I'm just going to wind up recopying -infinity to +infinity. Decreasing intervals, there are none. All right, it's all uphill. So that is it for problem number 3. That's all we were asked to do. All right, let's do that one more time. All right, so let us graph number 4. Are they not asking us for the domain and range this time? I guess not. All right, so all we got to do is graph it. So this time there are 3 pieces. Interesting. So let's see what we have. So first let's do this piece. So when you look at this, you should be thinking y equals -4. Y equals a number is a horizontal line. So this would be a horizontal line at -4. Okay, it would be like this. Okay, so here's my horizontal line at -4. Okay, can I have an interesting color for it? I'll make it orange. However, we do not get to keep this entire line. We only get to keep the part that is less than or equal to -1. So we'll go to -1 and put a point. It'll be a closed circle because of the or equal to aspect of it. So let's go to -1 on this line. So here's -1 right here. Boom. So there's my closed circle. Okay. Did it really just disappear like that? They did me wrong. -1. Don't disappear this time. Okay, now we want the part of the graph that is less than or equal to -1. So looking at this, we are going to go to the left because of the less than aspect of it. So I'm going to start here and I'm going to go to the left. So that's what that's going to look like. Okay, what's next? So let me delete this orange line real quick. Okay, so next we'll do this one. Now this one is not a horizontal line. Okay, when you look at this x, you should be thinking y equals x. Now that's not y equals a number, this y equals a variable. That means this is a diagonal line. It means it starts out at a y-intercept of 0 and it has a slope of 1/1. So I would start off, if I were graphing this line, I would start off at 0 and then I would go up 1/1 like this. And I could continue the process the other way. Okay, I already see that I'm overlapping with the other one, so there's no need to go any further than that because I shouldn't be overlapping. So obviously I don't get to keep this entire line. I only get to keep the part that's between -1 and 3. So let me make those points a little bit bigger. Okay, and they will be open circles. So I'll put an open circle at -1 and 3. So here's the point that's at -1, and here's the point that's at 3. All right, so let me start by erasing them and replacing them with open circles. So here's the point at -1, and here's the point that's at 3. All right, so when you have a variable between two numbers, that means we're supposed to draw the part of the line that's between those two endpoints. So that's what this piece is going to look like. Notice open circle, because it's not or equal to, not or equal to. And I will erase these extra points here. All right, so that's it for the pink part. Now for the green part. Now when I see this number 1, I should once again be thinking y equals 1. All right, so this is a horizontal line at 1. So that's going to look like this. Okay, so there's my horizontal line at 1. But I don't get to keep the entire line. I get to keep the part that's greater than or equal to 3. All right, so here is the point that's at 3 right here. It'll be a closed circle because of the or equal to part. Okay, so boom, there's my closed circle. Don't disappear. Boom, don't disappear. Because it's greater than or equal to, that means I'm looking to the right, all right, because of the greater than aspect of it. So greater than or equal to 3 would look like this. All right, it's that part of the line I get to keep. And I'll just erase my little guideline here. And that's it. That's what this graph would look like. Okay.